All right. So now we're going to talk about continuous random variables. Looking at the probability density function. Yesterday I showed you how to plot the histogram, how to work out the probability. Now we're going to look at the probability density function. All right. So you need to understand what the probability density function is for a continuous random variable and the conditions for the PDF to be valid. All right. Now this is the same as the probability mass function for the discrete random variable. Okay. Same condition, same way of testing it. You must be able to calculate simple, compound, and conditional probabilities with the uniform distribution. And I'm going to do the non-uniform distribution today as well as in the triangular distribution. The reason why I'm doing the uniform distribution and the triangular distribution is that they are both geometric. You could use the area formula to work out the probability. All right? So I've shown you this yesterday. I'm not going to go through it. It's just there to remind you the difference between the discrete random variables and the continuous random variable. Now, probability density function. A continuous random variable x has a probability density function. The probability density function, PDF, of fx can be used to describe the likelihood for a range of possible values of the CRV. The probability density function of a CRV can be exemplified by a rule or a graph. All right? So today I'm going to concentrate more on the graph rather than the rule. Tomorrow we'll do a little bit more on the rule. Okay? Fx can be geometric, for example, rectangular, triangular, and trapezoidal. Today I'm going to talk about rectangular and triangular, and those two, trapezoidal, is the same idea as well. All right? And all can be defined by the variety of functions. Let's start off looking at testing the validity of the PDF. So to make sure that the PDF of a CRV has to be valid, all the value of fx must be greater than 0. Remember, probability has to be greater than 0. All right? And that's a certain domain. You got to think about the domain between A and B. And then the area under the graph must be equal to 1. So you got to think about either using the area formula or using your integration. When I say minus infinity to plus infinity, it applies to these two limits there. All right? Unless it is E. E will go all the way across. All right? So remember, definite integration is a summation of all possible value of fx. All right? So it's area under the graph. So for a uniform CRV, so if you wish to generate any real number, this time the word real number is there, between 1 to 6 inclusive. There's infinite possibility. There are lots of values between 1 and 6. Could be 3.3333, 0.00001, 5.999999. So that's actually infinite possibility. So if x represents the possible value that can be generated, then x is an example of uniform continuous random variable. All right? The possibility of generating 2.5 is the same as the probability of generating a 4. It's the same as the probability of generating a 5 or 6 or whatever. All right? And it is uniform across from 1 to 6. Yeah? It's important to realize that we are looking at 1 to 6. And we refer to the distribution of probability as a uniform or rectangular distribution. Now, so look at this. The closed circle means that it includes the value of 1 and 6. Whereas the open circle there, it just means that the point is not included. All right? So the arrow indicates that everything beyond 1, less than 1 or beyond 6 is 0. Okay? Now, let's derive the probability density function of fx. So if this is a rectangular distribution, And we know that the area is 1. That's the definition. PDF. The area is 1. So we know that this times that equals to 1. Correct? So K in this case is therefore 0.1. Now, this is a graphical representation, but we can write it this way. Fx is 0.2 because K equals to 0.2 for between 1 and 6. But for all other values of x, it is 0. Alright? Yeah. So you know that we're generating from 1 to 6 only, all the real numbers. Everything is 0.2.
Wait, was it 6 take 1?
And for all other values of x,
the area
is 0.
of the curve.
Right.
Oh, it's only 5
so the area of the curve here, the area here underneath that is 1. Yep. Always 1. That's the definition.
Assertion.
Yep.
1 over 5 equals 0.2.
0.2, yeah, sorry. My typing. I got that right, but my typing is wrong there. It's 0.2, thank you. Yes, I'll change that. Alright, I'll change that when I upload that. It's my typing. Alright, so let's generalize it. No, generalizing it if I've got A and B. The limit of A and B, and that's K there. You know the area is 1 equals to B minus A, that length times K. So therefore, K is 1 over B minus A. And to write it out, instead of a graphical representation, it's just Fx equals 1 over B minus A for the domain between A and B, and 0 for all other values of x. Now, with a uniform distribution, by symmetry, the mean or the expected value of the distribution is therefore right in the middle, A plus B divided by 2, because it's uniform. And therefore, the median is actually the same as the mean. Correct? Yeah? Because right in the middle, 50% will be below the middle, 50% will be above the middle. Alright, so think about it. For uniform distribution, it's a rectangle, pretty straightforward. Mean is right in the middle, median is right in the middle. And it's A plus B divided by 2. And to find K is B minus A, 1 over B minus A. That's all.
Yeah.
Alright? Now let's do some example. Let's determine the probability for the given density function.
3 on 5.
Alright, looking at this,
1 and 5.
straight away you need to be able to find the area. That's it. Nothing else. You're given K. You're given this is between 1 to 6. So you should be able to find the area. Which is this?
Yeah.
This 5 minus 2 times 0.2, which is 0.6. Oh, now, because you have learned integration, we will do a bit more integration tomorrow. You could use differentiating between 2 to 5, 0.2 dx. You'll get the same answer. Now, I would advise you, if it is uniform, just use the area. Makes life a little bit easier for yourself. Alright? Same with 5 and 6. This is 0.2, or you can do the integration. I mean, this and this, I'll prefer that. Area. Alright, happy with that? I'll move on to the next. So now, same thing. Let's look at this situation here. You got to find K. What is K?
0.
This time is from 1 to 5. It's not 1 to 6 anymore. Alright?
Oh, yeah.
So you should be able to find what K is, which is
1 on 4.
Yep. So it's 0.25 or 1 over 4. I mean, really doesn't matter if you give it in decimal places or decimal place or decimal or whatever you call, or fraction. In this case, not a big problem. Now, can you work out x is less than 3? Pretty straightforward. Just the area there. So what I would do if I've got a graph there, I would just sketch the area so I know exactly where it is. Yeah? And of course greater than 2, you know it is area here. The reason why I would do this is because I would like to know whether it's this area or that area. So I know it's less than is to the left, greater than is to the right. It just makes life that little bit easier if you've got the visual representation. So the next bit is going to be interesting because we are looking at x is less than 3. Now, of course, you know that when I say x is less than 3, it's actually between 1 and 3 because the limit is there, the lower bound is there. Yeah? Nothing less than 1. So it's between 1 and 3. And then between 2 and 5. So see, I've highlighted between 2 and 5. And now less than 3. Less than 3, although it's from between 3 and 1, but you're given that the probability occurs between 2 and 5, so therefore we are looking at this strip only. X, which is less than 3, that bit only, between 2 and 3. Right? So we're going to use this over all of that. And then, using the area, it works out to be 1/3. I mean, even looking at it visually, you can see that this is one area out of 3. Yeah? So for uniform distribution, it's pretty straightforward. Okay, try that please. A if less than A equals to 0.8. Right? Again, I'll use the graph. Something like this. Try that please. Use the area formula. A minus 1 times 0.25 equals to 0.8. And if I got it right, it should be 3.2. 4.2, sorry, not 3.2. A minus 1 is 3.2. A is 4.2. Now, to make life easy for myself, rather than using 0.25, I use 1/4. Because 4 times 0.8 is 3.2. Yeah? So when you look at question like this, depends on whether it's in calculator free or calculator assume. Sometimes it makes sense to use a fraction. Alright? Try this one please. Again, I would say sketch up on the graph first. It makes it just with the visual, it makes it just that little bit easier. Alright? So it's greater than 2.4, something like that would be 0.6. Alright? Draw that first. You can work out the area. Something like this. Now I'm going to reveal my answer. 3.44. Use the area formula in this sort of situation. Especially a rectangle. All happy with this? If you're happy, we'll go on to the next bit. Alright, example 3. A continuous random variable x is uniformly distributed in the interval of x is greater than or equals to 2 and less than or equals to 10. So can you state fx is probability density function? What do you need to do in the first place? You need to find, you know that this is going to look like this, right? 2 and 10. And anything after that is 0. All right? So you know this is k. You need to find k first before you do anything else. All right? So how do you find k?
10 take 2 divided by 1. Or 1 divided by that.
All right? So if you're not sure about the question in this sort of situation, sketch this one out first. Sketch the graph out so that you know what's happening. So then what you need to do is to write it out. State the probability density function. It did not ask you to draw. So you need to state it. State which is fx equals to 1 over 8 between 2 and 10 and 0 for all other value of x. Alright? So that's what you need to do. I mean, I've seen certain book use this equals to 0, x is less than 2, 1, 8, 2, x 10 and 0, x is greater than 10. That's correct as well. Yeah? But that just makes it a little bit easier. Alright, so determine the expected value of x. Because this is uniformly distributed, it's just 10 plus 2 divided by 2, which is 6, right in the middle. Then, can you try those two, please, before I review my answer? Now that you've got those, again, I would suggest you sketch the graph if you want to. Or write it out as probability statement. So less than 5. But then there's a lower bound there which is 3. So it's probability between x, between 3 and 5, over probability between 3 and 8. Alright? So you know that there should be, let's stay on sun. So here there should be a lower bound between 3 and 5 because they are given the condition is between 3 and 8. So you need to find the area between 3 and 5 and the area between 3 and 8. And it's 2 over 5. So part D is trickier. Now you must be prepared to be able to sketch or draw properly if a grid is given to you, the distribution. Alright, so it's greater than 7. It's somewhere here. Alright, let me show you. If it is greater than 7, and you know that the upper limit is 10, this is 7, and this would be n. That over that is 3. over 11. Ooh, hang on.
Yeah, no.
I drawn that incorrectly. Sorry, my fault. Oops. The red one I've drawn incorrectly is greater than 7. Yeah, oops. Wrong. Yes. So it's between, this is 7.
And it's to the right. Would that be in that side?
And should be somewhere.
Yeah.
Can't be less than 7, that's not good.
And should be somewhere here. Alright, that's better.
G and equals 7.5.
Read it correctly as well. So
No,
work
I
that
got-
out.
I mean, I don't know if I'm right, but I got
Sorry?
8.875.
Something like 71.
Yeah,
over
78.
8.875 if you want. If you are in calculator assume section, I mean, they cannot say that you are wrong if you give it as a fraction. That's not a big deal as well. Or 8.875 or 8.88. If there's no mention of 2 or 3 decimal places, I don't think they can mark you wrong for giving 2 decimal places. In this case, you're looking for n. N is 8.88, that's fine. If you write down 2 dp, or just give it as a whole number, exact value, which is 71 over 8. Alright? Either one, that's fine.
Because
Alright. Next,
it's going from 2 to n.
we're going to look at another geometric distribution. We're going to look at
No.
triangle. Now, for a triangle, it is not a uniform distribution. But it is geometrical, so we can use the properties of a triangle to determine the probabilities. Now, it could be symmetrical or asymmetrical. Alright? So that is symmetrical, that is asymmetrical. So which means the distance between A to C is the same as the distance between C to B. Whereas this one, A to C, is different from the distance from C to D, asymmetrical. Not a uniform because it goes from 0 to that value and that value down to 0. Same thing, 0 to that value down to 0. Therefore, it's not uniform, not like a rectangle, but still geometric. You can use the idea of area. Alright? So, can we determine the peak of a triangle? If we know A and B.
Yes.
Yep. So this time, you know A and B. B, half of A and B times K equals to 1. So therefore, B take away A times K equals to 2. And therefore, K is a function of, I don't know why I use C. It's 2 over B minus A. It's my typing. Alright. Oh, it is FC, correct, because it's a function. Function of C. The value of C is there, correct.
Yes.
Yep, function of C, FC, that point, this function here will give you the same value as this function here, FC, that's correct. Right, it's 2 over B minus A. So the uniform is 1 over B minus A, whereas the peak of a triangle is 2 over B minus A. This applies to both the asymmetrical and symmetrical triangle. Alright? Now, for a symmetrical triangle, expected value of the distribution is A plus B over 2. Also the mean and the mode. See? This is where it happens the most. Therefore, it's a mode. As compared to uniform distribution. Uniform distribution, is there a mode? No. The mode is this one. Alright, same with this, the mode is that one as well, asymmetrical. Alright, you find the peak is the mode. So for symmetrical, that is the mean, A plus B divided by 2, median and mode. Alright, example 4, I've already given you part B. So let's have a look at this function here. Consider the following probability function. Sketch the graph of y equals to fx, labeling the coordinates of all critical features, hence describe the shape of the distribution. Alright, so if you could actually sketch it, please. Alright, you know between 0 and 1 is y equals to x. And then from 1 and 2 is 2 minus x. How do you do it? I did not give you a grid. In the exam, you might be given a grid, you might not. It depends on whether it's a sketch or plot. So it is a sketch in this case. How do I do that? So you know this is fx, this is x. Alright? Let's say this is 1, this is 2. Alright? So you know that anything anywhere else is 0. So anything below that is 0. So from 0, that would be the 1 point. Correct? And y equals to x. You know when x equals to 1, y equals to 1. So there's 1 point there. Agree? Now, the next bit here. How do I find the other point? The other point, use the x-axis because you know it's this is a straight line. Yeah? You know it's a straight line, 2 minus x is a straight line, and the gradient is that way. So if you substitute x equals to 2 in, that's 0. Yeah, the end point is 0, so therefore it's this, that way and that way. Alright, and if you draw it properly, you know that it is actually symmetrical. It is symmetrical. Alright? So the coordinates of all critical features intercept and peak. So if you label this properly, that's fine. If not, put down the value 1, 1. This is x is 2, 0, and 0, 0. Yeah? Label that. Or, if you got it on the graph, the axis, it should be fine. Alright, describe the shape of the distribution. A symmetrical triangle. Distribution over the interval 0 and 2. Okay? So this is how you do it. Of course I cheated. I didn't draw it by hand, but here I showed you how to draw it by hand. Alright? So that's how you should think about drawing it. Sketching it. So now from there, can you determine probability of x less than 1.5? Of course you can. Now here, if it's less than 1.5, you know that this is half symmetrical, that's 0.5, correct?
Yes.
So you need to find this area here. 1.5. Okay? You can use the area of a trapezoid. That is 0.5. You can work out this value and you can work out that value. Correct? Yeah? So therefore, that's how I did it. Half plus half times 1 plus half times half. Alright? 1 plus half, this is half, times half, this is half. So therefore it's 7, 8. It's just how it goes, that's all. And then think about probability of x less
I
than
got
2,
the answer, but I didn't do that.
but greater than 1.5. So it's greater than
I found a
1.5.
small triangle and
Now,
did the opposite.
here, x less than 2 is this way, correct?
Yeah.
But it's given that x is greater than 1.5.
It's 1 over here.
Alright? So you can work out the probability between 1.5 and 2 and probability greater than 1.5. And you can straight away see that the limit is that although it's greater than 1.5, it should be at the upper bound too. Yeah? So this area has to be the same as that area, which is 1. And then the expected value is, of course, 2 plus 0 divided by 2, which is 1. That's all. Because it is symmetrical. All right. Last example. Consider the following probability density function for the continuous random variable x. All right. You've got fx equals to 3x over 8 and 3 minus 9 over 8x for those values there. Now you need to be able to show that it's a probability density function for x. How do you do that? To
Find the area.
find the area, and that's one other thing that you need to know.
Equaling to 1.
All
No,
fx
all has to be
between
positive.
0 and 8 over 3 must be greater than 1.
Yeah.
Alright, so those are two things that you need to satisfy. So the area under y equals to fx over 3 between 0 and 2 plus the area of this between 2 and 8 over 3 must be 1. That's one condition. The next condition is all the value of this between 0 and 2 must be greater than 0, greater than or equal to 0.
Forgetting this.
Here, same thing as well. It cannot be negative. And you can work out that that's true. Alright, between 0 and 2, fx equals to 0, f2 equals to 0. So therefore, you know that you can plot it with 2 points already. Between that and that, you know you can plot that. Alright? And the points are 0 and 0, 2, 3 quarters. And then following the next bit, you've got that. So you could actually sketch the graph, which looks something like this. Now, you can do that, or you can, by doing that, you can actually say that everything is greater than 0. Therefore, one of the conditions is satisfied. The next thing is look at the area. You can use your triangle area. So you can use your formula of triangle to find the area, or you can use I wrote down as an integration, but I use the area formula to look for the area. That plus that, and that equals to 1. Alright? Now, 30th percentile. What is the 30th percentile?
130.
It's 1/3. So you know that it's not going to be here. It's going to be around here.
Is
Correct?
it 1/3 or 1/30th?
30th percentile is okay.
Yeah, it is
It's-
130.
It's 3 over 10. So the probability is 3 over 10.
No,
Yeah,
yeah.
yeah.
3 over 10.
Yeah.
It's not 1/3, it's 3 over 10. So it's 30th percentile. So you can't use this area. You're just going to use this line here, the function here. Look for the area here, which is about 3 over 10. Okay. So, oops, that's how I did it. K is somewhere there. And let the 30th percentile be K. So you integrate between 0K equals to 3 over 10. And I did that integration because in my mind that was a little bit easier. I could work that out. And therefore, K is K squared is 805. K is plus or minus square root of 8 over 5. Now, although you've got plus or minus, you've got to reject one of the value.
Minus.
Minus value because there's nothing below 0. Alright? So reject that, and therefore, you've got K equals to square root of 8 over 5. Alright? So, or simplifying it, rationalizing it is 2 square root of 10 over 5.
Wait, so is the 30th percentile from 0 to k?
Sorry?
So from 0 to K.
0 to K, yeah, 30th percentile. So this is
Okay.
Because like
this is
Yeah.
0% down,
True, true, true.
10, 20, 30, 40, 50 until 100%. All right,
Okay.
100% is 1.
So would you like say the interval from 0 to root 8 on 5?
Sorry?
Would you say the 30th percentile is 0 to root 8 on 5?
No, you're just looking for K. You're looking at the value of K. You don't have to say that it's a percentile.
Okay.
K is the 30th percentile. That value there. You're looking for K.
Yep.
All right? Or you can use the area equals half BH.
Yeah.
If you want to do that, that's fine as well. Which means the third is half times K. Here, substituting it in is 3K over 8. Yeah? You will get the same answer as well. Oops. You get the same answer as well. That is the same as that. It follows through. So it's up to you. I mean, here I've shown you two methods. If you sketch it out properly, perhaps using the area is just a little bit easier. All right? All right, I'm going to stop here. And you've got enough exercises to do in, I think I gave you